Section 7.4 is about, well, it's about Lagrange multipliers, but first I want to do a couple of problems not using Lagrange. So I wrote no Lagrange. So we want to minimize the function so here's a multi-valued function, f of x comma y, and we want to minimize it. So the function is x squared plus xy plus y squared. We want to minimize this subject to the condition that y has to equal negative 26. Well, this is pretty straightforward because if y equals negative 26, I'm just gonna plug that negative 26 into here, and this becomes x squared minus 26x plus negative 26 squared, which is 676. And I want to find the minimum now of g, and we know this is a quadratic, so we know from algebra that the minimum occurs at negative b over 2a, which is in this case 13, because it's positive 26 over 2. And so the minimum occurs when x equals 13. Just write that equals, I didn't write that equals x. And we know that the minimum is going to occur when y equals 26, because we're forced to make y equal to 26, negative 26. We have no choice. So I'm going to take x 13 and y negative 26 and put it into my original equation right here. So I get, because that's what I want to find the minimum of. So I get 13 squared plus 13 times negative 26 plus negative 26 squared, and that equals 169 minus 338 plus 676, which equals 508. So therefore I could state that the minimum value of f is equal to 507, and it occurs at the point 13 comma negative 6. Now I want to do a second problem, and again, we're not going to use Lagrange multipliers here. I want to maximize the function f of xy equals 8x plus y, subject to the condition that x squared plus y equals 8. Now I made a whole bunch of arrows here, so let's just look at it. Okay, so starting with this condition, I'm going to solve for x. So first step is to solve, and I get x equals 8 minus x squared. Now I sub this into my original equation, my first equation, and that gives me this guy right here. So instead of 8x plus y, I have 8x plus 8 minus x squared. And now I want to find the minimum of g. Well, before I did negative b over 2a. Now, just for fun, I'm going to do it a different way. I'm going to use calculus to find the minimum. I'm going to look at g prime, which is 8 minus 2x, set that equal to 0, solve for x. I get x equals 4. So the minimum occurs when x equals 4. Well, what's y going to equal? Now I follow this arrow over here, and I plug in x equals 4 to this guy right there. So I get y is equal to 8 minus 4 squared. Instead of 8x squared, it's 4 squared. Y equals negative 8. So my x value is 4. My y value is negative 8. The point where it achieves the maximum is 4 comma negative 8. And the actual maximum value that f will achieve is 8 times 4 plus y, which is negative 8, which is comes out to a grand total of 24. And that is how we do that.